Hi guys, this is Himanshu and I will be discussing about vector in this video. So this video is specially for beginners but intermediate coders might also get some info from it. So what I will be discussing is what are vectors, some ways to initialize vector, some common functions of vector and difference between implicitback and pushback, and also I will show you implementation part. So let's get started. So what is vector? So vectors are basically dynamic arrays. That is, unlike array, you can use them to store any number of elements and can insert or delete more elements as per your requirement. Now, internally, vector uses array to store their elements, and the elements are stored in contiguous locations. So how vector are implemented using array and provide a lot of functionality like dynamic size. I will discuss about this in another video because it is interesting to know the concept of how vector works, and this might also be asked in interview. And another thing to notice is you can use this operator to access vector instead of using iterators. So the advantage of this is that you can basically treat vectors as array but with a lot more functionality. So now I will show you some common functions of vector. Before before moving forward to common functions, I will show you some ways to initialize vectors. Since vector is a class, it provides a lot of constructor to initialize vector. You can simply initialize a vector, you can specify size and a default value, you can initialize it like array, and also you can use another container to initialize a vector. So let's look how can we do this through some code. Here I have defined a print function to avoid writing this for loop again and again, and these two lines specify my input and output files. And one thing to notice is that always pass vector by reference, because by default vectors are passed by value. And so the problem with this is that whenever you call the function, the whole vector will be copied first, and this will increase the time complexity of your code. And with pass by reference, only the pointer to the vector is passed. So now let's see how can we initialize vectors. So this is how you simply declare a vector, or you can even use vector of vector. Okay. So these are three vectors which I have declared, and a vector which will store integer, float, and a vector which will be storing another vector of integers. Now let's declare a vector with a default size and a default value. So this is how we do this. I will be creating a vector of size 3 with default value 1. Now let's print it. You can see we have got 3 1 here. Now you can also use this constructor to initialize a array which is already declared. Let's see how we can do this. So I will be initializing vector b, which I have already declared here. It will have 4 value with 5.5 as its default value. Okay, now let's print this. Uh, Here I have used a range based loop, which is basically it will get every element inside B and we can use that element. So we can see we have got 4 values as shown here. Now let's see how can we initialize these types of vectors. So you can create another vector using this constructor, and I will be using the one which I have already declared. Basically this will have 4 vector of integers, and each vector will have 3 integers with a value 2. Now you can use range based loop or with simple indexes. and int j will be checking the size of. First we are traversing the whole vector of vectors. The size function returns the size of the vector, so this will return the value 4. Now when So now at every index we have another vector of integer. So we will be traversing that vector with this loop. Here we will get the size as 3. Let's run it. Now you can see here we have got 4 rows with in each row there are 3 values. This is how you can initialize a vector with a default size and a default value. Now let's look how can we initialize a vector just like an array. So this is how you do this. So we have just inserted some default values. Let's print it. I have already used name D, so let's use E here. And you can see we got these 6 values. And you can also use another beautiful way to initialize a vector with the help of another container. So what I mean by that is, let us declare another vector with name F, and I will be using vector E to initialize this vector. So basically what it requires two parameter, which is the starting iterator and the end iterator of the container whose value we want to insert. So, so basically begin returns the iterator pointing to the first value, and end return the iterator to the end of the array. So the whole range of E will be copied into F. Let's print F, and you can see the values are copied directly. And the another container does not need to be a vector, it can be a set too, or a map. So let's see how can we use set. I will be inserting some value. Okay, so if you don't know what set is, I will be creating another video on set. So now let's use set to. Now I will be using set to initialize the vector. So basically what it requires is the iterator to the first position of the container and the end. And this is how you get the iterator. Now let's print the value g. And you can see we have used set to initialize this vector. So these are some of the common ways to initialize vector. Now we will see some common functions which return iterator. So these are some of the most common one. Begin will, as you have already seen, begin will give the iterator to the first element and will give the iterator to the end of the array. Remember, this is not the last element, it is the end which points to the which stores a null value. And the R begin will give a reverse iterator which will start from the end. That is the last element. So the pointer will be at the last element and it will be used to traverse vector in the reverse. R end will be the end of that reverse iterator. So let's see this in code. Okay, so let's check the beginning value. Remember, the iterator is basically a pointer, so we have to dereference it first and insert a new line. See, we got the first element. Now we can use iterator to traverse the array too. And this is how you declare an iterator. First you define the STL of which iterator you want, then the iterator keyword, and then IT. So I have assigned the beginning, that is the first pointer to the first element, and will traverse till we haven't reached the end, and then keep on increment the iterator. Since iterators are pointer, we have to dereference it and print the value. And you can see we have printed whole value. Now let's see the reverse iterator. So basically our begin will be the beginning from the end. So this will print the last element of the vector E. Let us check it, and you can see we have got the last value. And this is how you define a reverse iterator. Reverse iterator, RIT. So we will be using this to traverse our array. E dot r begin and RIT is not equal to IT plus. Sorry, we are using RIT here. Okay, so it is R begin. It's a typo. So we have traversed the whole vector from reverse. And the time complexity of all these functions are constant. Now we will see some common functions that are provided by vectors. So these are the some common functions that are available to us. The size, as we have seen already, returns the size, and the empty returns a boolean value which tells us whether this vector is empty or not. And front and back are used to access first and last element. So let us check them in code. Let us check these function. Now e.size should return 5 because there are 5 value, and e.empty should return 0 because e is not empty. And we will be also checking front value, which is 1, and e.back, which is last value, which should be 6. So we can see we got 5 for the size, 0 for empty, 1 and 6 for front and back. So these are some basic functions. Now let us check pushback and ImplaceBack. So pushback and ImplaceBack are used to insert element at the end of the array. So they both perform basically same function but in a slightly different way. And the time complexity for both of them is a constant. So why is this constant? I will be showing you in the video where I will be describing about the internal structure of vector. So now let us look at these two functions and the difference between them. So now let us first see the use of ImplaceBack and pushback. So pushback will be pushing 7 here, and ImplaceBack will be using 8. Let us print E here. So as you can see, we have inserted two values with pushback and ImplaceBack. So the basic function of both of them is same, but there is a slight difference, and that slight difference make ImplaceBack a little bit faster in some of the cases. So the difference is that pushback might create a temporary object and then copy the value in that object before assigning it to the end, whereas ImplaceBack directly forwards the value without copying. So the copying time is saved by the ImplaceBack. So what I mean by that is, let us see here. Suppose we have a vector of string. So string is a class. Let's call us stringback. Now if we push back high in this string, sorry, it is stringback. The thing that happens behind is this. It creates a temporary object of a string and then copy the value in that temporary object, and then that temporary object is pushed at the end. Whereas if you use in place back, there is no object created and the values are directly passed without copying. So this is what makes in place back a little bit faster than pushback. Now let us print the value of string. Strings. For auto strings in string back, print the value. What happened here? Oh, sorry, it should be string back and it should be strings. So these are the three values that we have pushed at the end of the string. And the another difference between these two functions is that pushback required exact object to be passed as the parameter, whereas ImplaceBack directly forward those values to the constructor. So what that means is, suppose we have a vector of vector integers. Let's call this a matrix. Now if you use pushback like this, it will result in a error because it requires exact object to be passed, which should be of a vector integer type. That is, if we do something like this, if we push e, which is already a vector, then this will work fine. But if we use in place back like this, sorry, it should be in place back. This will not create an error. Instead, what it will do is it will be directly passed to the constructor of the object, which is this. So as we have already seen this type of constructor, what this will do is create a vector of size 3. So basically what this will do is insert another vector at the end with size 3. Now let us check it, and you can see we have got three values with 0. These are some of the difference between pushback and in-place back. Popback is the opposite of pushback and in-place back. It deletes the last element. Let us see here. So RE have these elements from 1 to 8. So if we will use popback, the 8 will be deleted. So now if we will print E, and we will get 7 values. So this is the popback for you. And just for a reminder, if you use popback on the matrix, the whole row will be removed. And let us use this on matrix. So this will remove this whole row of last row because this is the last element of matrix. See, we got only these values. First I will show you clear, then I will show you insert and erase. Clear simply clears the whole array. So it will delete the whole array. So if I will use this on, let's say, string back, it will clear the whole array, that is delete whole value. We can check this by using empty function. Remember, it should return 1 now. My bad. That means string vector has become empty. Now insert and erase, as the name specify, are used to insert or erase elements from anywhere in the vector. So there are three ways to insert element. Let us look at all three of them. So first way to insert is we define a position which will be an iterator to where we want to insert the element and the value which we want to insert. So now let us insert into E. We will insert at the beginning first. And the value we will insert 0. Let us check this. So as you can see, we have inserted 0 at the beginning. Now another way to insert is like this. We can specify the position which will be the iterator, and we can define how many times that value should be inserted. Let us denote this by size and the value. Now I will be inserting at the first, starting from the first index, that is after 0. So let's see how can we do this. I will be inserting 2 times, and the value which I will be inserting is 4. Now let us run this, print the E. So you can see we have, starting from the first index, we have inserted 2 values, 2 fours. Another way to insert is we can specify the position where we want to insert and use another container to insert. So for another container, we will first define the starting position of that container and the end of that container. So let us see how can we do this. I will be inserting at E, and this time I will be inserting at 0, 1, 2, 3, third index. It will be, and we will be using set to insert the value. So I've already declared a set with values 4 and 5. And now let us print E. So you can see from third index we have inserted 2 values 4 and 5. So these are the 3 ways with which you can insert value in the vector. And now let us look at the last common function of vector, which is erase. There are 2 ways to erase the element. So the first way is to specify the iterator which we want to erase. I will be erasing this first position, value at index 1. So that will be e dot begin plus 1. Let us print e, and you can see the first index is deleted. Another way is to specify the range which we can delete. I will be deleting these whole 5 elements. So from beginning, and see we have deleted all these 5 elements. And the complexity of both erase and insert function is linear, because we need to shift the value after inserting or erase. Now one thing to remember is that if you are using iterator to traverse the array and are using insert or erase function at that time, so the iterators might get invalidated. What I mean by that is, suppose if you are traversing the array, let's see this way, using iterator, and you have some condition for inserting or erasing. I will be commenting these two for this because we want 4 here. And you have got some condition like this. If the value is 4 and you want to erase this, now let us check if this work or not. As we can see, one value of 4 is not deleted. So why is this happening? So the reason is that when we perform insertion or deletion, the iterator from the point where we have performed the function are invalidated, because after erasing or insertion the pointers might need to change and then they might point at different value. So this causes the program to behave abnormally or may cause runtime error. So just remember this thing. So hope after this video you will know how to use vector and things to take care of.